Audio metering is ever present in our digital audio workstations, and for a good reason. In the courses before, I already talked to you about the peak and RMS metering, so let's go through that again because it's very important. We can measure the peak value of our signal, and that will be the current value of any sample at any given moment. So actually the peak value follows this line. It follows the amplitude of our signal. So when I play the song, you can see the peak value right there. That's the current value. Actually, these two small lines represent the maximum value in the last 2 seconds. But the darker meter you see in the back is the one that actually follows the amplitude of our signal. Now, the greener one, the lighter line right there that reaches slightly less value, is the RMS value. RMS is a root mean square value, meaning that it gives us the average value of the signal. How does it give us the average value of the signal? Well, let's presume that right here we have 44,100 samples per second in this digital audio. It's going to take a number of those samples, let's say 300 milliseconds worth of those samples, add their values all together, and then divide that value by how many samples there were actually in that period of time, and give us an average signal value for that period. That RMS value up in the front, this greener, lighter one, is actually the value that gives us an average value. It's more close to how we actually perceive the loudness of that sound. In a sense that if we have a lot of transients, it's not going to sound that much louder to us. All of these small peaks right here that are peaking, that's not what makes the sound as loud as it is the actual average value over time. Now, that didn't used to be such a problem in the old days when we had the mixing consoles, because everything was measured with the VU meter. A VU meter was the standard for broadcasting and radio, and VU meters, using that needle on the VU meter, let me just find one in one of the plugins. So I think the NLS has one. VU metering, just like this one, and you might recognize this from if you ever seen an audio console in a video, at least, if not in real life. You've seen these VU meters, and they actually have a needle right there with a counterweight that is moved by an induction circuit. So it actually has some integration time. It has 300 milliseconds of integration, just like our human ears. That means that it represents the levels coming out of here much more faithfully to the loudness at which we actually perceive them than just this actual peak value right there, which is just momentary. To our ears, more relevant is this RMS metering and this VU meter. What they show us is more close to how we actually perceive the loudness and the actual volume of that sound. That being said, we do use peak metering in digital audio and analog audio to actually see how hard our signal is pushing. So we need to see what is the maximum value that our signal has reached at any point in time, any given point in time. That means that right here, if our signal passes the 0, we are going to have digital clipping. So I can play this right here, and then I can pull up on the value of this audio, let's say just here or even here, and show you that it will be clipping on the output. So get ready, this is going to be probably much louder than the actual song is. So don't be alarmed and pull the volume down just in case. Well, I'm gonna move the song to a point further in time, like right here where I see there is louder points. There are louder values in the signal. So let's do that. As you can see right there, we surpassed that 0, that maximum value of our full scale or full digital scale, which means that we are clipping substantially, even 4.5 dBs over the top. So that should never happen. And this is why we use limiters. We just talked about it in the level before. Now we use peak meters to actually measure those kinds of value. What is the maximum value that our signal has reached at any given point in time? But if we actually want information about how loud our sound is. The peak value is probably the last thing that is going to tell us anything. So we're probably better off looking at something like this VU meter or looking at something like that RMS meter that we have right there. So even when mixing, if you want to see how loud things are comparison to one another when you're mixing them together, if you want them to have, let's say, similar volume, I think that RMS would be a much better decision and a better bet of what's going to actually show you the loudness, the subjective loudness as you hear it and perceive it. Now, in the lessons before, we also talked about gain staging, and you can see right here that once I go over a certain threshold, with this signal, it actually points this needle of this VU meter onto 0 and never goes back. So let's see that once again. So you can see that VU meter is going to show you a much more realistic picture of how the sound is moving. So any fast movement in the sound, any fast peaks like this one happening are actually not going to be portrayed on the VU meter. And it's actually going to show you the loudness of the sound in the way you hear it. So we have that peak metering, we have the RMS values, let me pull this down, we have the RMS value, and we have actually the VU meter, which you can find in many plugins. You can even find VU meters like this as a standalone meter that you can watch to actually see how loud your sound is to your ears. Now, aside of those values, also another really good type of metering that we can use would be the metering that shows us phase correlation or stereo separation for that effect. So in span right here, the meter that I always show you, that I always use, you can see right there that in span we have this correlation meter right here. So I'm going to keep this volume down just so I can play the song and have some signal to talk to you about and actually be able to talk to you so you can hear me over the music. So immediately you can recognize the span analyzer. But one thing we have in span is this correlation meter right here. Now, correlation meter is going to show us the stereo separation. It's going to show us the correlation between the right and the left channel and show us how different the phase of those two channels is. Now, the difference in phase between the left and right channel is going to show us how stereo something is, since if there is no difference in phase, signals are identical. If left and right signals are identical, we have more or less a mono signal being played out in the left and the right channel at the same time. Now, when that correlation actually starts to differ, and mind you, at 1 right here, the phase of both of the signals is exactly identical. As it goes away from this number 1 into -1, it becomes more stereo. So at -1, the phase of the left and right is completely opposite. At 1, it's completely identical. At 0, somewhere in between, exactly in between. So you can see that every time the kick punches right here, the overall signal becomes much more mono. Why? Because a kick drum has a really high energy and really high volume compared to all the other sounds. And once it hits, and because it's mono, it's going to make the entire signal much more mono, much more correlated between the left and the right speaker. In between each one of the kicks, the signal is quite much more stereo because everything that's left are all the melodies that are really stereo and really wide. So essentially, correlation meter like this one shows you how stereo something is. Now we have other meters like goniometers, and let me try to find one like that. Okay, so right here in the ozone, we have a goniometer right here, or vector scope as they call it. And this meter is actually going to show us that stereo image like that. And we can show it like this too, like this too. So we can see how stereo our song is. Now mind you, if I turn that into mono, just right there, let me just turn it mono completely, yeah. This is what we have when the song is mono, just so you understand what this metering is showing you. So this is when we have an identical signal on the left and the right as we have now, because I made it so with the utility. In the polar too, just like that. And right here too, see? And as the signal becomes more stereo, as I'm introducing, starts spreading out. You see that? Now, if I make the signal completely stereo out of phase, it's just gonna do this, be completely, you see, horizontal. Now you don't hear it, I can even let you hear that. So right here, you can analyze by the sounds and see what is actually giving you more stereo, what's giving you more mono, and you can use scopes like these to actually measure how stereo your signal is. What these do is actually also show you phase correlation between those two speakers, but they actually do it for, so what those actually do is they show you how stereo your signal is. So we have meter that shows us the amplitude of the signal, and then we have meterings that show us correlation between the phase of the left and right channels.